With the ability to travel past 2,147,483,647 within the usual far lands, you may be wondering, do we ever encounter a new set of far lands? In the beta versions, there is a theoretical third set of far lands at about 7.662 billion blocks out, when a noise generator known as scale noise overflows. However, much like with the other Octave sets of far lands, no visible change can be seen. As I mentioned earlier, there are occasional shifts in the terrain of the edge farlands, especially when they extend from the corner farlands. However, these turn out to just be the diagonal lines from the original corner farlands, as you will see in just a bit. Like right here, you can see the diagonal line that leads up to that 1 block thick line you saw over there. We can also see the final state of the edge farverland. Since the ratio of x minus 12,550,824 to z minus 12,550,824 in this case is increasing as we travel further along the x-axis, the edge farverlands simply become increasingly similar to how they appear at 1,004,065,920 in the x-axis and around 12,550,824 in the z-axis. The same applies on the z-axis. Wait, what? The top of the terrain here is only at 119. Yeah, you could clearly tell that the top of the edge farverlands when x was at 1,004,065,920, and z was much further out, was at 127. If you remember, earlier in the video I showed the northeast quadrant on this seed, which without the special patch that moves the diagonal lines in the other quadrants, will usually start as a mirror image of the main quadrant's z side. That is the area that I'm showing right now. However, the height of the tops of these floating islands there was also 127 rather than 119. And this is because the value of the noise generator that's generating these higher areas is actually at y equals 120 is actually approaching 0. As the z fraction gets larger, as the ratio of the z fraction to the x fraction grows larger. Other than that, though, this area of the farverlands is shaped exactly identical to the other area I just showed. This is actually another visible manifestation of the second Octave set of farlands. Around 89 million blocks out on the x-axis on this seed and 121.94 billion blocks out on the z-axis in this seed, we see the beginning of the jump in the tops of the edge farverlands on this seed. Again, if you remember at 12,550,800 on the x-axis and 1.04 billion on the z-axis, the top of the terrain was only at 119. Yeah, we see the edge farverlands jump up to 127. Awesome. In fact, the jump in the terrain does not reach 1.04 billion on the x-axis until about 684 billion on the z-axis. In fact, most seeds have at least one y sampling point where this occurs. In the seed, take the seed minus 147212826259886 of course, which features a thin layer at y equals 96 near the x side of the southeastern corner farlands. This layer is only 1 block thick. And it is not mirrored in the southwestern quadrant on its x-axis side. Like normally, you can see where I have teleported. Normally, by this point, the structure of the corner farlands would be the exact same as it is on when traveling in the positive x direction. But here, it is not quite the same. That thin layer at 96 is actually not there. But there's more. If we set the x noise multiplier very high on this seed, we can see that normally the edge farverlands that come off from the corner farlands, normally these would reach their final state by 1 trillion blocks out. And and once they reach their final state, they will be mirrored in the negative direction. But we can clearly see here that even 10 trillion blocks out, which is of course 100 right here, which is now equivalent to 10 trillion blocks out on the regular world of this seed. The edge farverlands are still not exact mirror images, which means that in the positive direction they have not reached their final state yet. Even 10 trillion blocks out. However, we can see that the layer is beginning to break up a bit as we travel further out into the tens of trillions. What is happening here? The reason for this is because the first octave is in its corner farland, but the second octave is in its edge farland. This means that the noise values of the first octave will be significantly larger than those of the second octave. The first octave's noise values would in this area would typically be on the order of the x quintic multiplied by a certain large value, which in this case would be the z quintic at the given z coordinate we are at. While the second octave's noise values are only on the order of its x quintic itself, which would be considerably smaller. But at this layer, the first octave's noise values of this noise generator, the noise generator is generating the thin layer, happen to be approaching 0. So what's happening is that the noise value there is getting smaller and smaller and smaller, or at least relative to what you'd expect from this area of the corner farlands. In fact, how much larger the first octave's noise values are than the second noise octaves depends on how far the other axis is past 12 million for 2024. But yeah, the first octave approaching 0 to travel. So eventually, the noise values of the first octave are approaching 0. So the second octave's noise values will gradually dominate eventually. And notice that this doesn't happen in year 25,101,648, or even like 10 or 100 times that distance. This happens like way out there compared to where the second octave begins overflowing. This is actually what I meant in that little blurb earlier in the video when I first went to 12 or 25 million on both axes. That most seeds do have visible manifestations of the second octave's farlands just much further out. By 100 trillion, we could clearly see that the layer is breaking up. A very rare instance of variations in the terrain within the otherwise unchanging edge farverlands. And by a quadrillion blocks out, the thin layer is completely gone. And the edge farverlands are now an exact mirror image of the negative side, compared to the negative side. We can also observe this at y equals 120 on the seed minus 3 quadruple 4 7 5 0 8 5 9 7 7 8 6 3 8 1 as we travel further out on the z-axis. The tops of the terrain here actually do not reach 127. There is actually a point where the tops of the terrain in this area will eventually reach 127. But here is the sort of breaking up phase of the layer, which would appear a quintillion blocks out on the z-axis on a normal world of this seed. Now, unfortunately, the terrain there would appear very stretched due to the noise coordinates themselves losing precision by that point. So you can see all these pillars, L-shaped artifacts, and sort of monolith, not really monolith, just like floating rectangular artifacts. This is actually, once again, the sort of breaking up phase of the layer, and eventually the tops of the terrain do reach 127 and become unchanging. However, if we went just a couple million blocks past 12,550,824 on the x-axis, the tops of the terrains would actually not jump up from 119 to 127 until well past the 64-bit integer limit. In fact, out in the sextillions range. Note note that these effects would actually appear without the Farthest generating. And here we see that the artifacts actually stop as we traveled a few hundred blocks in the x-axis. Actually, there's a few more over there. But now that we travel a few hundred blocks in on the x-axis, the artifacts are pretty much gone. And that's because the noise values on the x-axis now are significantly larger than even just a few dozen blocks past 12,550,824. And again, because the edge Farthest are actually affected on the corner Farthest when they extend from the corner Farthest. So these effects would actually appear without the Farthest generating. In fact, the position I'm at right now is equivalent to 10 sextillion blocks out on the z-axis on a regular roll with this seed. However, after 25,101,648 on the x-axis, the jump in the terrain on this seed begins to appear much earlier, because we are now in the corner Farthest of the second octave. And in fact, up to a certain point, the further in we travel on the x-axis, the earlier the jump will appear. By coordinate scaling, we can easily view the whole mathematical curve. The earliest the jump in the terrain appears is around 89 million on the x-axis, around 121 billion on the z-axis, which is actually the tip shown earlier in the video a little bit. And then after that, it becomes more similar to the normal diagonal lines in the corner Farthest. Note that in a regular roll of the seed, it would be much more stretched out on the z-axis than this, because on this roll I had the z multiplier set 1,000 times as much as the x multiplier. In fact, the same thing will eventually happen with the thin layer in the other seed. In fact, the same will happen with the thin layer on the other seed. Although this doesn't really support my case. But note that the whole breaking up phenomenon, the layer breaking up phenomenon can only occur between 12,550,824 and 25,101,648 on the other axis, along with the edge Farthest not reaching their final state until ridiculous distances, as I have shown. Once again, after 25,101,648, the edge Farthest will begin to reach their final state much earlier, closer to 1 trillion blocks like I originally thought. Another example of this can be seen at y equals 112 on the c minus 3 quadruple 475085977863881. If you remember, when I showed the area around 1.04 billion on the x-axis and 12,550,824 on the z on this seed, if you remember, there were some 1 block thick lines 8 blocks higher than the 5 block thick one, like the line that you see right here. You can see that there is a line a bit higher up. And these continue till in this case around 10 quadrillion blocks on the x-axis, when we can see this line starting to break up here. And eventually this line will stop. And y equals 112 will become an air gap as it is near 1,004,065,900 on the z-axis. Now, the ridiculous coordinates where this phenomenon occurs actually directly correspond to how quickly the quintic equation applied to the noise coordinate fraction values grows after 12,550,824 for low and high noise. Or rather, whenever the noise coordinates begin overflowing. In areas where the corner Farthest have 1 block thick layers, like here, we can also observe how the biome fill noise Farthest appear to be a third set of Farthest, although they are not really. You can also see how the final state of the edge Farthest over here is an inversion of in the main quadrant when we traveled further along the x-axis, and 1,465,920 on the z. You can see that these dips directly correspond to the floating chunks in the positive direction, and at positive 1,4,065,920 in the z. Note that the edge Farverland's final state is also mirrored in the negative directions, and when the other axis has the same sign. We can also now view the final state of the diagonal line from earlier, which by this point becomes much more wavy. The pattern continues to repeat up until the noise coordinates themselves lose precision. After the discovery of the Farverlands, two more sets of Farlands were theorized: the Farver-lands, which were supposedly the 64-bit equivalent of the original Farlands, and the Farthest lands, which are supposedly the 64-bit equivalent of the Farverlands. However, if we teleport to where the Farver-lands would purportedly appear, we find nothing. And the same goes for the Farthest lands. However, in the 1.12.2 Forge mod I used, a bizarre ridge would occur at the expected Farver-lands distance, which I have managed to replicate here. In fact, this is the Farver-lands. The Farver-lands eventually revert back into the Farverlands, with some layers gradually dropping off, and the edge Farverlands within them gradually transitioning back into their previous state, with the Farver-lands finally dropping off back into the Farverlands at twice the distance they initiate at. Although apparently some artifacts can occur after that. And in fact, when changing the selector noise scale on one axis, we could find the edge Farthest lands, which I have again replicated here. The edge Farverlands are structurally identical to the edge. The edge Farthest lands are structurally identical to the edge Farverlands on that axis in that seed. And once again, they gradually revert back into the corner Farverlands, as you will see in just a bit. Like, notice how all the artifacts gradually fade out here and just revert back into the corner Farverlands. Now this was actually caused by the modulo being changed from 2 to the 24th to 2 to the 63 minus 1 rather than being fully removed. The first octave's noise coordinate goes back to 0, so the second octave, which is still overflowing, will now dominate, because the first octave would be generating normal terrain, which would be dwarfed by the other octaves, which are still overflowing. But then once the second octave gets knocked down, by that point the first octave is again long since overflowed. So it will dominate. So the first octave will dominate again. And when enabling the Farver and Farthest lands on the C-3 quadruple 4750859778381, when traveling along the z-axis, we see that the strips at the top of the edge Farverlands remain unchanged in the edge Farver-lands, confirming that they are an artifact related to second octave's Farlands. And if we teleport to 2,008,131,840 on the x-axis, we can see the edge and corner boundary of the Farthest lands. By this point, the edge Farverlands and have thinned out, so at this point, the edge Farverlands are much shorter than near 1.0. The edge Farthest lands, by this point, the edge Farthest lands are much shorter than near 1.04 billion in the x-axis. In fact, the point where they revert to corner farverland becomes earlier the further past 1.04 billion the other axis is. And a sort of, and one thing, as I showed earlier. There's also a strange diagonal around 2.08 billion in the x-axis, which would really be a huge mathematical curve. This is again because the farther and farthest lands are actually the second octave farland. Basically, the second octave farland and farther lands. You'd see the same thing for the edge farther lands at 25,101,648 in the other axis, but it would be pretty hard to tell because that's still within the edge farther land. The corner farther land will simply appear as a ridge within the corner farland. Notice how this layer, which is in the corner farverland, just drops off right here. And the edge variations of the farverlands near the corner farverlands actually look identical to the corner, because it is really just the second octave's farlands within the farverlands. As we travel further along here, the layers will eventually transition back to how they generated before the ridge. And in fact, within the edge variation, we can see some mathematical curves. These correspond to the noise coordinate on the x-axis of the first octave getting larger, and it hasn't been knocked down by the modulo yet, while the z noise coordinate has been knocked down by the modulo. And at twice the farther distance, or 107.81 quadrillion blocks in both axes, we see another ridge where the corner farther finally revert back to the corner farverlands, although the positions of the diagonal lines will still be slightly different than before the first ridge. Notice how some of the heights of the layers will actually begin transitioning a bit before the reversion. Occasionally, this can be seen as a jump or drop in the top layer, around 100 quadrillion blocks out on both axes. And then there's the corner farthest lands. Once again, the edge farthest lands, right up to them, appear exactly identical to the corner because the edge farthest lands really only exist within 2,008,131,840 on the other axis. And in the edge farthest lands, near the corner farthest lands, we can see some mathematical curves that are more similar in nature to the diagonal lines of the corner fartherlands, in the same way that those mathematical curves within the edge fartherlands are similar to the diagonal lines of in appearance to the diagonal lines of the corner farthlands. The farthest lands will also revert at twice the distance. And within the corner farthest lands, it is also possible to see some diagonal lines turn into mathematical curves near the reversion. Notice how this diagonal line, which resembles the usual diagonal lines in the corner fartherlands, curves more and more toward the x-axis as we approach the reversion of the farthest lands, at twice the farthest land's distance. And actually, even curves around a little bit right here as we get. Once again, the farthest lands will revert at twice their initial distance, or 8.624 quintillion blocks out. The new hard limit was 9 quintillion, 223 quadrillion, 372 trillion, 36 billion, 854 million, 775,807 blocks out. However, just when you thought no one could break that,